Relative frequency and probability. We're going to imagine a little warm-up activity where you're going to toss a coin 20 times and record the results in the table. So let's say you toss the coin and these are the results. First result is tails, second toss is heads, third toss is heads, and so on. Now, in the end, we're going to be interested in how many times did each event occur? How many times did we get heads? How many times did we get tails? We can see we got heads 7 times. We call that the frequency. Frequency just refers to how many times something happened. The frequency of tails is 13. Now, relative frequency, which you'll see is in the title of this page, relative frequency is the frequency compared to the total number of trials. So the relative frequency of heads, we'd say, is 7 out of the 20 trials, 7/20ths. Of course, we can simplify that or rewrite it as a decimal, 0.35, or we could say it's 35%. So the relative frequency of heads is 7/20ths, or 35%. The relative frequency of tails, on the other hand, is 13/20ths, or 65%. Now, some comparison here between relative frequency and probability. Relative frequency is the fraction or percentage of trials in which the event occurred. Probability is a prediction of the percentage of trials in which the event will occur in future random trials. 0 for relative frequency means the event did not happen. Out of all the 20 trials, if we didn't get any tails, the relative frequency of tails would be 0. A probability of 0 means the event can't happen. A relative frequency of 1 would mean the event happened on every trial. A probability of 1 means the event is guaranteed to happen. Both relative frequency and probability involve the idea of the complement. The complement is the event didn't happen. So if we're looking at the event toss a coin and got heads, the complement of that would be got tails. And if we do a trial a bunch of times, the relative frequency of the complement of an event is 1 minus the relative frequency of the event. Looking back to our coin example, the relative frequency of tails was 13 out of 20. That's 1 minus the 7 out of 20 that we got when we flipped heads. For probability, the complement is the same idea. The probability of the complement of an event is 1 minus the probability of the event. So the complement of getting heads in the next coin toss is getting tails. Now, some similarities. Some similarities and differences between probability and relative frequency. First, one similarity, both are a number between 0 and 1. A number closer to 0 means it occurs less frequently. Closer to 1 means it occurs more frequently. That's true with relative frequency and with probability. The difference is relative frequency generally refers to what has happened. It's about the past. Probability is a prediction about the future. There are 2 main ways to estimate the probability that an event will occur. First, through a theoretical model based on equally likely outcomes. Second, we can estimate probability based on a relative frequency from past observations. So a theoretical model based on equally likely outcomes. A coin is an example of this. A coin has 2 sides, and we think they're equally likely to appear when a coin is flipped. So we say there is a probability of 1/2 that the next toss of a coin will be heads. The 2 in the denominator because there are 2 possible outcomes, heads and tails. The 1 in the numerator is because one of those outcomes is a head. Rolling a die is another example. When a die is rolled, what is the probability of rolling a 5 or a 6? There are 6 equally likely outcomes. our event, rolling a 5 or 6, is made up of 2 of those outcomes. So the probability is 2/6. Now I know you're told you should always reduce fractions, but many times in probability questions, it's better not to reduce the fractions. Because when there are 6 outcomes, it makes more sense and it's clearer where you got your answer if you leave it as 2 out of 6. And also, when we want to compare probabilities of different events, having that same denominator is sometimes helpful. Now we've used a couple terms here, outcome and event. When we think through a theoretical model, as we did with rolling a die, the equally likely things that can happen are often called outcomes. So the outcomes for rolling a die are 1, 2, 3, 4, 5, or 6. A set of those outcomes can make up an event. The event, rolling a 5 or 6, is made up of the 2 outcomes, rolling a 5 and rolling a 6. This theoretical approach, then, gives the probability as the number of outcomes in the event divided by the number of all possible outcomes. The other way to estimate probability is to use the relative frequency of an event in past observations. For example, in our coin toss experiment, we might say that our estimate of the probability of heads based on our experiment is 7 out of 20, or 35%, because that's what we saw in our experiment. We don't really think that's quite right. We really think that the heads and tails are equally likely, but maybe we got a weird coin. Maybe for this coin, the probability was 35% of getting heads. Of course, another experiment would probably give a different result, and therefore a different estimate. But the more trials you do, the closer the relative frequency gets to the actual probability. In the next video, you'll see some examples of some homework problems. Thanks.